Hello everyone, welcome back to your channel. So in the previous video, we had started with what is LangChain, right? We were in the phase 3A, right? So today we will start implementing the one of the components of LangChain, that is the message objects. So I have already created a folder phase 3A LangChain, okay, and in that I have created two files, that is chatbot langchain.py, in which we will be writing the code to create that message object, okay. And already we have kept that llm.py, right, which will give us the client to connect with the foundation model, right. This we have been repeatedly using all of these, right. Let's start. First, from llm module we need to import get llm, right. Then from langchain import the messages to import one message, AI message, then system message. So from the LLM module, we are importing the get LLM function, right? And from this lecture coded message, we are importing this. And these are what do you know? What are these? These are basically classes. Classes, right? In Java, there are classes, right? So we will be creating objects. You see how we will be creating objects for this. Okay. Classes. So classes, constructors, right? Getting this intuition. Just classes, constructors, right? How we call the classes, right? How we create object for those classes. Remember? Similar kind of things you will see here. Let's just so the moment the moment we run this file, this function will get executed and we will get a client to connect the foundation model in some better. Right. See, we had written get LLM function, right? To create and return a client to connect to the foundation model, right? Same thing. Once this is done, that's what. What? Okay. First, there will be a conversation history. We need to mention that conversation. Uh, that be a list. In that, first let me add that system message. See how we'll create a system message. Where we will pass it, right? Parameterized constructor, right? We will pass the value. Right. This will pass the prompt, our previous prompt, right? Yes, right? This is the system message, right? So this is what initially we are storing in the conversion. Okay. Um, let's keep it outside so that it is accessible globally, right? So that it is accessible globally, right? This is right. Correct. Now let's say it takes question the parameter, right? So now question comes. So what we need to do? We need to create a message, right? A prompt that will be sending to the LLM, right? So it will be that chat history, right? Chat that means conversation history, conversation history, right? Whatever we have is having initially is the history, right? Plus human message, new message object, right? Content is equal to. So basically, what we are doing here, first of all, understand here. See this conversation. history is a list, right? That is is storing the history, right? Right? That will be storing the history. And what it will contain? Will contain the message object. What are those message objects? The message, right? And message, AI message, right? Getting. So this is the list we have created for storing the history, and it will contain the message object. And in what terms it will store the elements? It will be message objects. And what will be those message objects? System message, human message, and AI message. Getting. That is what we have done. So initially, what we are doing? Initially, adding the system message and creating the conversation as the global list, so that can be just anywhere in this file, right? It is outside the method, outside the search subfunction, right? Getting. Now we have created a function defined chatbot in which we have created a variable in which we are taking what is the conversation history, that is whatever there is already existing in the history, and then we are adding the new human message that has the content as the new question that has arrived, right? This has the new question arrived, right? So basically in Python what happened, suppose there is a list that has value 1, 2, 3. There another list that has a value as 4, 5, 4, 5. And when you do plus, when you do plus, it will get merged and it will be converted in 1, 2, 3, 4, 5. So that is what we are doing. Conversation history has already some message objects, right? And to that message object, we are appending a new human message object with the content as the new question letter. Getting right? That is what we have done. Now, after that, what we will do? LLM dot book book what? Oh, sorry, messages book, right? So this will give font, give font, right? Uh, that's it will return that client, right? And that client will be stored in this LLM variable, right? Now, in the conversation history, we will append, right? Append. What we will append? First of all, we will append the human message with content equal to question, right? Then we will append human message, right? With content equal to font dot. Let me return here the font dot. Let's create a new function, define name. We'll first of all take the question as the input as a while true. It will take the question as input, input question is right. Then skip question dot lower, right? Equal to what? Equal to exit, right? Event break. Else chatbot, and this will return the content, right? Right. So Print what? Print is that AI message on print. So this will happen, right? If it's not an exit, then it will again go for asking the question, right? We want this main function to be executed only when this file has been right. Command operator is right. So let's run it. Then I will make you understand like what basically solved, right? And what basically is still pending. Why? What happened? AI message, not import AI message. Oh, okay, okay. Okay. What it will be? It will be a capital A, capital AI. By mistake, I have done both times here message. It will be AI. Was a AI message, right? Was a message replied from AI, right? That content. Run it. So that is ask the question. Thing. First answer was the reference, like, and let me ask, see that it's able to remember the previous content. Let's say ask how it works basically. Let's this able to get the context or not that I am talking about like right? How it works basically. How it works basically. It is able to get the context, right? Language. So the memory thing that we were able to implement in manual memory, same thing through LangChain also we are able to implement, right? Now you would be thinking, okay, in the last two video, like when we were discussing this one, we had mentioned that we are creating a manual memory, right? Calling every time, injecting the history, right? All these problems. So is this problem being solved here? Uh, yes. Is that problem being solved here? No. We are still maintaining manually the history. If you see here, still we are creating a array, right? To maintain the history, right? List. Still after the response, we are storing by ourselves that human message and AI message, right? So this is also manual memory kind of, right? So what did it solve? Why? What did it solve? If you remember, before sending request to that LLM, right? Before sending request to that LLM, every time we are converting that history into text. See here, remember before sending that history to the LLM, first we were converting that history into text, right? And parsing was required, right? There was not a standardization. Okay. So what LangChain did that it asked, it enabled us with standard message objects. So these are standard message objects, right? Let me type it down here. Type it down. Yes, here also. So we are kind of manually maintaining a list, maintaining a list for conversation history, right? Yes, the question is 100% valid and it's true, right? Here also we are manually updating the history on the question or response, right? what did it solve? Right? This is the question, right? What did it solve? So in manual memory, there was no standardization for storing the messages, the history. So LangChain here provides the standardized message objects, that is one message, right? One message, AI message, the one message, right? And each of these message objects are understandable by the LangChain component. That is no need, that is no need of parsing. You see, we just created those objects, added in the history, and along with the current question that we send to the LLM. Unlike like previously, we didn't need to convert the list text for sending prompt to LLM. Right? This thing we didn't require to do. This thing is there now. So this was not required. This we didn't feel the need, right? Right? Just what we did here on, right? Conversation history plus new message object representing the current question. Conversation history plus conversation history, right? That is the storing the history of those objects, and the current and the new message object representing the question, right? And we were able to get success, right? No parsing required to be done, right? No parsing required to be done, right? No parsing required, right? So this is what LangChain was able to solve. If you see the some of the previous courses of your videos, there used to be LangChain conversation, LangChain buffer memory, right? So these were kind of implementing the auto memory. Okay, but these are the legacy or deprecated classes. So what I am going through in this video through code is latest LangChain. So the verb is able, right? So sir, how will we be implementing that auto memory? So for that, we'll be going to LangGraph. We'll have checkpointers concept where through which this auto is checked. So in tomorrow's video, we will see like what this LangChain couldn't solve, right? What is the problem with this stage? Okay, and then in the next video, we'll start with the LangGraph. I hope I was don't think this LangChain just as a memory thing. Okay, it consists of several components, right? Framework, pre-built. That's already I have discussed in the previous. And don't think that it has a auto memory. Okay, so these are some of the misconceptions that I'm trying to improve. So that's all for today. Keep coding, exploring, and